friends, here this is Anshika Gupta. Today I am going to explain about the photoelectric effect, its experiments and its contradictions with the wave theory. Now first of all we should know what is photoelectric effect. Photoelectric effect is the emission of electron by the action of light. Okay, the photoelectric effect is the emission of electron by the action of light. There are certain metals like sodium, potassium, rubidium, calcium shows the photoelectric effect with the visible region light, and the metals like zinc and cadmium shows the photoelectric effect with the UV radiations. There are some non-metals also which shows photoelectric effect but with the shorter wavelengths, and there are some liquids and gases also shows the photoelectric effect. Now there are many scientists who observe the phenomena of photoelectric effect like Hall-Walsh, J.J. Thomson, Heinrich Hertz, but they are failed to explain what it is. But in 1905, the giant scientist Albert Einstein successfully explained about this phenomena. Now comes to the experiment. Here we have the experimental setup for showing the experiments on the photoelectric effect. Here we are going to use a glass tube, which is in vacuum, so the retarding of electron does not take place, and the glass tube is provided with a quartz window because here we are going to use the UV radiations, so for which the glass is opaque. And here we are going to use two electrodes. One is emitting electrode and one is collector electrode. Emitting electrode act as cathode while collector electrode act as anode. Here we have provided a micrometer for measuring the current and voltmeter for measuring the voltage. Here we have a potential divider which is used to vary the potential. Here we are going to use slits which is used to vary the intensity of light, and we can vary the frequency of light by using different color filters. Now comes to experiment first. Experiment first is variation of photoelectric current with variation of intensity. Here by keeping the frequency and voltage constant, we get the graph between the I and between the current, photoelectric current, and the intensity which is linear. This what it shows. It shows that the current, photoelectric current, is directly proportional to the intensity, which is our first law. Now come to our second law. What is it? What it is? It is the variation of potential. How variation of potential? If we apply varying potential, then what happened with the photoelectric current? Let us see. Here we have a graph between the potential and the current. Okay, for different intensities we have drawn. This point is known as cutoff potential. We should know what is cutoff potential. Cutoff potential is the maximum retarding potential. Is the retarding potential at which the flow of electron stop or the current becomes zero. And this is the negative potential, which is also known as retarding potential, and this side, left side, we are going to use positive potential, which is accelerating potential. And this region is known as saturation current. Saturation current, and this is the maximum current produced in a photoelectric effect. It is a maximum photoelectric current. Okay, and for any mass of, sorry, I have pointed this at a cutoff potential, but it is not. Here it's the cutoff potential. Here if we have the mass of electron m and velocity is maximum, then half mv square is equals to ev naught. Okay, as we all know that half mv square is the formula for kinetic energy. So kinetic energy will be maximum because here the velocity is maximum and mass is not varying. So kinetic energy is equals to ev naught. Here we can clearly say that the kinetic energy does not depend upon the intensity. Here this is our second law, that is kinetic energy does not depend upon intensity.
V max square ऊपर एकदम.
Okay, this kinetic energy does not depend upon the intensity. This is our second law. Now comes to the third law. The what is the effect of frequency on the photoelectric current? Here we have a graph for the different frequencies. Here we have a graph for the different frequencies. What we see that the potential increases with increasing frequency, or the potential increases with increasing frequency, and when the potential increases, then the kinetic energy also increases. So we simply conclude that the kinetic energy increases with increasing frequency. This is our third law. Now comes to another graph. This graph is between the potential and the frequency. Okay, this graph is between the potential and frequency. And here from this graph we can see that we get a straight line which does not passes through the origin. So this graph shows that we have to apply some V naught or the nu naught frequency to emit out an electron, because it does not get emitted at the zero frequency. So we have to provide some frequency. This generates a new concept of threshold frequency. Threshold frequency is the minimum frequency needed to pull out an electron from the metallic surface. Okay, and the fourth law of this is the process of photoemission is very instant. Okay, all the four laws we have. That first law is photoelectric current is directly proportional to intensity. Kinetic energy does not depend upon intensity. Kinetic energy increases with increasing frequency, and the photoelectric emission is very instantaneous process. All we have four laws. Now comes to the next topic. Our next topic is its contradictions with the wave theory. Wave theory simply can explain the phenomena of reflection, refraction, diffraction, interference, but it cannot explain this phenomena, photoelectric effect. So why it cannot explain this phenomena? We should so to answer this question, let us move towards our next topic. What is our first law? Now starting from first law. Our first law is photoelectric current is directly proportional to intensity. So this law can easily explain by the wave theory, as more the intensity, more the energy, and more the electron emitting out from the metallic surface. Okay, so this law can explain from the wave theory. Now comes to the next. Now comes to the second law. What our second law says? Second law says that kinetic energy does not depend upon the intensity of light. So it cannot be explained by the wave theory, as more the intensity, more the kinetic energy will be. So kinetic energy should increase linearly with intensity, but it is not as we have seen from our experiments. So this law cannot be explained by the wave theory. Now comes to the third law. Our third law says that kinetic energy increases with increasing frequency, but it cannot explain by the wave theory, as we put the certain frequency for longer time on the metallic surface, that it should have enough energy to emit out an electron from the metallic surface, but it is not so as we have seen from our experiments. And the concept of threshold frequency should not be there according to wave theory, but it is so as we have seen from our experiments. So this law cannot be explained by the wave theory. Now comes to our fourth law. Our fourth law is the photoemission effect is very instantaneous process, but it cannot be explained by the wave theory, as from Huygens principle the radiation energy is distributed over the wave fronts, but over the wave fronts, and the energy incident on each electron should be very small. So the energy required to emit out an electron comes after some time, and there should be some time taken by the electron to come out from the metallic surface, but it is not so as we have seen from our experiment. So it is all about our photoelectric effect. I hope you will understand well, and for next video wait for some time, and I will come with my next video, and subscribe our channel to watch more learning videos. Thank you.